Let's take a look at recursion mathematically, then we'll take a look at recursion in Prolog and see how that relates to the mathematical recursion. So if we want to compute, say, the factorial 5, so 5 factorial, in maths this is equal to 5 times 4 times 3 times 2 times 1. We just count down the numbers from 5 and take 1 off at each step. So if we do this, we get 120. Let's see how we can write 5 factorial using recursion. So with recursion, we need a base case and we need the recursion rule. So we need two parts to recursion. So let's write the base case first. So we noticed when we got down to 1 we stopped. So the rule is, the base case is 1 factorial equals 1. This is called the base case. Okay, let's now write the recursion rule for our factorial. So let's make the 5 any number and call it n. So n factorial equals, what did we do for the first step? We took away from that n, or 5, we took away 1 there, and that becomes our new factorial. But then we times it by our n. So if you take a look up here and take the 5, put the 5 there, 5 take 1 is 4, so that's 4 factorial times 4. So 4 factorial, so in our case above, if we had 5 factorial, that it would equal 5 take 1 factorial times 5, which is equal to 4 factorial times 5. Notice that 4 factorial is actually this section here, and the 5 is that part there. So this line here has given us the a breakdown of that 5 factorial, but not a complete breakdown. But if we keep using this recursion step here, we will get down to the full breakdown of 5 factorial, or any number we choose. Okay, so let's apply this rule here to the 5 factorial and get the full breakdown, 5 times 4 times 3 times 2 times 1. So as we just mentioned, we start with the 5 factorial on the left. That equals 5 take away 1 factorial times 5, which is equal to 4 factorial times 5. We now do the same operation, this recursion rule here, to the 4 factorial. So we do that same operation, 4 take 1 factorial times 4. That's our recursion operation, but we still need to add that 5 in there, so times 5, which is equal to 3 factorial times 4 times 5. You can see how we're sort of starting to expand out with what we have up here. We do the same recursion rule again on the 3 factorial. So that is equal to 3 take 1 factorial times 3. We still have the 4 there, and we still have the 5 there. So this is equal to 2 factorial times 3 times 4 times 5. Okay, we do the recursion rule again on that 2 factorial. So that is equal to 2 take 1 factorial times 2 times 3 times 4 times 5. and we'll just go up here. So that is equal to 1 factorial times 2 times 3 times 4 times 5. But we know from our base case that 1 factorial is equal to 1. So now we can terminate here and write this is equal to 1 times 2 times 3 times 4 times 5. And there we have our answer. So it's just written in the opposite order here because our rule is written, if we had the n on the front there, we would have the same order as here, 5 times 4 times 3 times 2 times 1, but we've just written it in the opposite order, 1 times 2 times 3 times 4 times 5. So that is the principle of recursion, and the same principle is used in Prolog to carry out recursion. We need a base case and we need the recursion rule. Okay, so now let's take a look at Prolog and using recursion in Prolog itself, and how the recursion in Prolog is the same as recursion in mathematics. So here we've got built-in predicates length, which are built into the Prolog language, which calculate the number of elements in a list that we supply it. But we can also define a recursion operation to carry out the to return the length of a list or the number of elements in a list. So here we have our recursion program here. Notice, just like we did in mathematics, we had a base case and then we had a second step called the recursion step. You can see in the recursion step we have the len function on the left and the len function on the right of the neck operator there, or the if operator there. We also have the predicate is here. Remember, is predicate takes the left hand side and a right hand side argument. So in this particular case, it just grabs the value of n1, adds 1 and returns that summation to n. So if we run this program in Prolog for a empty list, we simply get 0. And if we run this program for a single element list with 1 element there, we get a value of 1. Notice on the left of the neck symbol, or the head of this rule, we have the vertical bar here separating the head from the tail of the list. So in this particular call to the recursion program that we supplied here, you can see there is 1 element to the head, but there are 0 elements to the tail